also reverberate in the environmental memory of Europe and Asia. But nothing had prepared humanity for the powers that would be unleashed during the 20th century. The mushroom clouds over Hiroshima and Nagasaki have been burned onto the retina of present-day global consciousness. The introduction of nuclear weapons into warfare has to be considered as one of the most important environmental events in human history, with its potential to wipe out and alter life across the planet. The further development of nuclear weapons since the Second World War even threatened the very existence of the human race itself. Nuclear warfare became the ultimate apocalypse and Armageddon. Small events can have enormous consequences on the course of history. Andreas Steele's development of the chainsaw in 1929 is such a small development which had huge consequences for the world's forest ecosystems. It heralded a period of greatly accelerated worldwide deforestation that continues to the present day. It has huge social, political and economic impacts, and the life and death of Chico Mendes is an example of this. The chainsaw is the ultimate example of industrial power unleashed on the ecosystems of the world and should be part of our collective environmental consciousness. For most of human history, societies have lived within an important ecological limit. Farmers in all agricultural societies relied on nitrogen-fixing bacteria to replace whatever nitrogen the annual harvest removed from the soil. Over the long term, the quantity of food that a society could produce depended on how fast bacteria could replace that nitrogen. The recycling of nitrogen-rich human and farm wastes, known as manure, helped, but that recycling was not enough. This limited the growth of the world's population. In 1913, two scientists at the German chemical firm BASF invented a process that could fix nitrogen from the atmosphere, and by doing so they could artificially improve poor agricultural soils. This removed an important limit on the increase of agricultural production, but it also led to environmental problems that are observed worldwide. Today, through the production of ammonia using the Haber-Bosch process and the unintentional fixing of nitrogen through combustion processes, societies fix nitrogen on the same scale as the world's bacteria, resulting in too much nitrogen entering the biosphere. The accumulation of nitrogen plays a role in increased levels of nitrate in groundwater, the formation of hypoxic dead zones at the mouth of rivers, photochemical smog, acid rain, the formation of fine particles in urban areas, and increased emissions of the greenhouse gas nitrous oxide. In essence, the fixing of nitrogen by humans has disrupted the nitrogen flow of the Earth system, and the consequences are complex and possibly long-term. The big blow-up of August 1910 climaxed with the great fires that swept the northern Rocky Mountains of the United States. They were the first great wildfires fought by the new US Forest Service, and some 78 firefighters died in the process. The experience traumatized the founding generation of the Forest Service and led to a total ban of fire from the state forests in the United States. This had global consequences, and as a result, in many countries keeping fire out of forests became an important policy. The result of this was the accumulation of fuel on many forest floors, and by the late 20th century it had become clear that fires were part of forest ecosystems and could prevent large blow-ups. Nowadays, in many parts of the world, preventative burning has become a common practice. In general, the management of fire is humanity's unique ecological signature, the one thing humans do that no other creature can. The big blow-up can thus stand for all the other choices humanity has made regarding its control of combustion, including the big burn of fossil fuels that is shaping the present age of the Anthropocene. In 1902, the US Reclamation Service was established, renamed into the Bureau of Reclamation in 1923. Its purpose was to develop arid and semi-arid areas for agriculture and settlement. But the Bureau is most famous for the large dams it built, including the Hoover Dam on the lower Colorado River, the Grand Coulee Dam on the Columbia, and the Shasta Dam in Northern California, all completed in the 1940s. The impact and influence of the Bureau of Reclamation on landscapes and river systems around the globe is considerable. It altered not only the river and land environments of the American West during the 20th century, its expertise also became one of the United States' most important exports, with the US helping other countries pursue similar strategies in the post-World War II era. With the growth of technological power in the 19th and 20th century came also a growth in applying these technologies to extracting resources on scales not seen before. Oil extraction is one, and open pit mining is another. Open pit or mass destruction mining is the process of digging away entire mountains or creating enormous pits for the extraction of metals or minerals. It leaves large scars in the landscape. By 1990 it was estimated that world open pit mining operations moved 20 billion tons of rock each year, making it a more powerful geological force than natural erosion. If global demand for metals continues to grow, the pressure to expand mass destruction mining will likely to grow with it. Although not yet part of the environmental memory of the world, it will certainly leave huge scars on the planet that will only heal with geological time. Climate change is the most prominent environmental issue of today. It has anchored into the collective consciousness beside the other major concerns of humanity, like religion, war and questions of justice. Like all collective issues, the response to this challenge differs greatly among individuals and cultures. Some display grave concern and suggest an array of remedies, while others deny its existence or walk away from any responsibility for dealing with it. Human-induced climate change challenges our understanding of history, our vision for the future, and the nature of our species. Wine production is an ancient art, and wine has been one of the most important agricultural products since antiquity. It is also part of a story that highlights the ever-increasing biological globalization that has occurred since at least the Middle Ages. The unintended arrival of phylloxera in Europe and its rapid spread in wine-growing areas around the globe almost destroyed the wine industry. Phylloxera are tiny sap-sucking insects related to aphids that feed on the roots and leaves of grapevines. They are native to eastern North America. In the 1850s it was discovered that a few American vines were resistant to mildew. This discovery led to a rapid increase in the importation of American vines into Europe. But with these vines came phylloxera, which spread like wildfire. Grafting of American vines to rootstocks of Eurasian varieties prevented a wipeout of the global wine industry. The replanting of vineyards required much capital and effort, but many wine growers failed and had to look for a new workplace. The arrival of phylloxera caused enormous economic and social consequences in all the wine-growing countries at that time. It is a reminder that biological exchanges are a driving force in history. Although the oil well at Titusville, Pennsylvania, drilled in 1859 was not the first in the world, it was the first drilled with mechanical power, using a steam engine. This well symbolizes the shift away from a coal economy to an oil and gas dominated one. The rise of oil has had one of the most pronounced effects on world history. It made the automobile possible, a development that changed the face of the planet and drove urban expansion in a way never seen before. The long-term consequences could even be more dramatic, with the growing indications that with burning the black gold we are altering the climate of the planet. As such, the triplet of energy history, transportation history and climate history are taking charge of the agenda of environmental historians. One of the world's great transformations in global environmental history has been the ploughing up of the world's grasslands to grow grain. The process began at the western end of the Eurasian steppes, in present-day southern Russia and Ukraine in the second half of the 18th century. In the 19th and 20th century, the Great Plow-Up spread to vast areas of the prairies and Great Plains of North America, the Pampas of South America, the Veldt of South Africa, northern India and North Africa, and the plains of Hungary and Romania. This process was driven by the transport revolution, aided by the construction of railroads, cargo ships, ports and grain elevators. Facilitated by domestic and international markets, the grain was consumed by the globe's burgeoning urban population. The conversion of large parts of the world's grasslands to arable fields was achieved with great social and environmental cost. Indigenous populations were forcibly driven off the land and their way of life, which was based on herding or hunting livestock, was destroyed. The Indian Wars of the late 19th century and the wars on the Eurasian steppes over many centuries between states based on farming and pastoralism opened the way to the plough. The ploughing of the fertile soil to grow grain was also followed by ecological disasters, of which the Dust Bowl on the southern plains of the United States in the 1930s is probably the most infamous. The ploughing up of the steppes is a story that is directly related to the rise of oil, nitrogen fixation as well as the transportation revolution, and is part of the environmental legacy of the 19th and 20th centuries. Between 536 and 551 AD, tree ring growth was very low throughout Eurasia and many other parts of the world. Contemporary writers in southern Europe described what modern climate scientists call a dust veil event that sharply reduced the amount of solar radiation reaching the Earth's surface. It has recently become clear that we are dealing with one or more huge volcanic eruptions in the tropics. These eruptions put enough dust in the atmosphere to affect the Earth's climate for years. The resulting depressed temperatures and disrupted weather patterns reduced biological productivity, including that of food crops, resulting in famine and social disruption around the globe during the 6th century. This event resulted in the transformation of societies around the globe, including in China, the Mediterranean, Scandinavia and the American Southwest. It signaled the dawn of the Middle Ages in Eurasia. Because of its scale and importance, this event should be part of humanity's collective environmental memory. The AD 536 event is an important test case for comparing the environmental resilience of different societies. The shift from hunter-gathering to agriculture is probably the most important ecological event in the history of humanity. The agricultural revolution is a global event because it happened in parallel developments in many parts of the world, although at slightly different times. Agriculture revolutionized the way people interacted with other species, which revolutionized the way people interacted with each other as well. It made complex urban societies and states possible, and everything historians study has been a byproduct of this. The myth of agricultural ideal, spring fertility festivals and many religious practices hark back to the period when agriculture began and shows the centrality of it in our global collective memory. Perhaps one of the crucial moments in the big history of the world was the crossing of Wallace's Line by modern humans some 50 to 60,000 years ago. Wallace's Line is the boundary caused by impassable deep sea trenches that separates the Asian and Australian zoogeographical regions. This resulted in the development of spectacularly different species in Australia and New Guinea because it was isolated from the rest of the world. Then, in the words of environmental historian George Seddon, it had a radically new technology imposed